Now we're going to look at vectors, which are a way to basically to show how to translate figures. But first we need to talk about the ins and outs of what vectors are. First of all, naming a vector. When we name a vector, we always start kind of like array. We always start with where we start, and then it goes through to the second point. So if we were to name this, we would name it ST, and then what we do is we draw a bar, and instead of putting arrow here, we just put 1/2 of an arrow. So this would be vector ST, and in component form, we put, instead of parentheses, we put like little brackets here. And if we count it, it would be 1, 2, 3, 4, 5, 6, 7, 8. So it goes -8 because it's going to the left, and then 0 because it doesn't go up or down. So again, the vector is called ST, and because we're moving to the left 8 and 0 units up or down, the component form would be -8, 0. Alright, so as you can see, when we go from ABC to A prime, B prime, C prime, and the vector isn't written very well there. Let me just cross that out and do it again. Because if you notice, it's 1, 2, 3, 4, 5, and down 1, and it's kind of covered up there, so it should be 5, -1. Okay? And it says to translate it. So basically what we do, this tells us the same thing as x, y leads to, because the first part is 5, we would go x plus 5, and the second part is down 1, so we'd say y minus 1. So this is just another way of writing what we have here, but we're doing it with vector notation. So the first point, which is at 0, 3, becomes 0 plus 5, which is 5, and 3 minus 1, which is 2. So there's our 5, 2. B, which is at 2, 4, becomes B prime. So it would be 2 plus 5, which is 7, and 4 minus 1, which is 3. And finally C, which is at 1, 0, would become C prime. 1 plus 5 gives me 6, and 0 minus 1 is -1. And if you notice, these 3 points happen to be these red points here. Okay? So again, when we do this, what we're really saying is we're saying 5 to the right and 1 down, and we connect them all. You notice the vectors are drawn from the pre-image to the image, and the vertices are parallel. All 3 of those should be parallel, otherwise these 2 figures won't be congruent. So we're going to name the vector again. This is vector RS, and in component form, this would be 1, 2, 3, 4, 5, 5 to the right this time, and 0 up or down. So there's our vector, and there's our component form. Here's another one. This time it would be, and remember, it has to start where the vector starts, so this would be vector tx, and in component form we're going up 3, so it's 0 on the x and 3 on the y. There's our vector notation and component form. Okay? And here's one more. This would be written as bk, and remember, not an arrow here. And then in component form, we're going to the left 1, 2, 3, 4, 5. So that's a -5. And we're going up 2, so it would be -5, 2. Again, there's our vector and there's the component form. And we want to translate using this. So if we look at it, L, which is at 2, 2. Again, what this means is we're saying x, y becomes, since it's -2, it would be x minus 2, and y would be y plus 6. So that's just another way of writing the same thing. So L prime would be 2 minus 2, which is 0, and 2 plus 6, which is 8. M would start out at 5, 3, and would go to 5 minus 2, which is 3, and 3 plus 6, which is 9. And finally, N, which is at 9, 1, becomes N prime. And it's 9 minus 2, which is 7, 1 plus 6, which is also 7. So again, that's converting it. We get 0, 8, 3, 9, and 7, 7. And that's it. We're done.